I'd like to start this talk with a little short story. Like 2-3 years ago, before the pandemic, there was an interview to the, at the time, CEO of Daimler, Dr. Zitchen, and the German journalist made a statement. He said to him, in the last 10-15 years, the enterprise value of big OEMs in Germany has been reducing, has been not growing as fast as other companies. What are you going to do about it? The question was hard. It was really tough because to the CEO to say your company is not valuable anymore, and especially to a big company like Daimler, was a tough question. And the answer was the car is going to be much more than a means to move from a place to another. It's going to be a soft-defined vehicle. That's what Dr. Ditcher said at the time, and this is what we're going to talk about today, is what is happening when the vehicle that we all normally use to move from a place to place becomes in reality a connected place that can be upgraded and updated in times. What it does, a software-defined vehicle, what it is essentially, it's like every software-defined object. It's an object that can be updated, upgraded, improved through times, where the life cycles of your experience through the vehicle changes, or to the object that you're using changes through times. But it actually has two important impacts. First of all, it has an impact on the users, the guys who drives the vehicle, because they are experiencing a vehicle that changes and improves its quality and the way it is used. And it has a big impact on business. So the company who produce the vehicles, the enterprises who produce the vehicles, starts to have possibility to have recurring revenue path that goes behind the sales of the vehicle itself or post-sales in the vehicle. So they start to gain data and other type of valuables that can be resold and re-engaged into the economical value creations. Essentially, how does this work? There are, of course, different approaches to software-defined vehicles. But from our point of view, from the point of view of those who manufactures and builds components to create software-defined vehicle, there are different possibilities that new revenues and new business and new experience can be created. First of all, software-defined vehicles are vehicles where performance can be improved in times. If you buy today a Tesla, you know that you can select a certain level of autonomy, and in time when regulation will come, it will be increased. It becomes also safer in terms of how safe it is, the vehicle, and secure. There is a possibility for the manufacturer to control the life cycles, and we will see later maybe the importance of partnership between our companies to exactly do that. That type of life cycles control comes through the possibility to store data, to maintain data, and to have it controlled in time. We have a number of software-enabled functions, which can be commodities, but can be also function that has to do with predictive maintenance or with even model-based control. So something that changes as the controlling system increases and becomes better. And of course, it's post-sale, as it is traditionally done. So this possibility to create more value through times became a fundamental transformational fact for OEMs, especially those OEMs who create vehicles that are experienced, that has content in it. And the way to build this software-defined vehicle from an architectural and then eventually electrical point of view starts always from the fundamentals and then builds on top of them. The fundamentals for software-defined vehicles are essentially always three. First, it needs to be safe, because we don't buy cars to get into an accident, so we need to maintain the level of safety. Second, is to be secure, because the content of the data, the content of what happens in and outside of the vehicle needs to be secured for legal reason and also for the utilization by the OEM. And then it needs to be future-proof. The third point is the key point. Future-proof is a quality, a characteristics, a features of a system that means that it needs to be prepared to be ready for tasks that are not yet known today. So it needs to be flexible and adaptive if you want, to the futures. And how does that work? So how does a software-defined vehicle get in the end organized? In the end, you need to think that inside the vehicle there will be point where data is connected, aggregated, pre-elaborated and sent to a centralized. All these software-defined vehicles, in fact, are built in layers, from the lower levels, which are the sensing and actuation layer, to a certain layer which are going to call hub today, right? This is the aggregation layer, zonal, sometimes called. And then the central computing engines that decide the way the feature of the vehicle will be applied. It's very important to understand what the hub means. Like in avionics system, a hub is a big airport where small planes comes in and are gathering, aggregating all passenger or goods into big, large plane for transoceanic flights. The same is in a vehicle. In a vehicle, a hub is a place or a zone, is the place where data, I/O, and power are managed, where there is an aggregation, controls of data and I/Os, and the power locations are controlled. Before, the data is abstracted and sent to the central units where more artificial intelligence based or more advanced control is done. This changes completely the way that the vehicle is designed, organized, structures. It changes the wiring harness. It changes completely also the way that the memories are deployed in the vehicles. Where are the physical memory for permanent data? Where are the dynamic memories for transformated or transformational data? So it's very important to understand this transformation is happening. It's going to take a long time to happen because it doesn't happen in 3 days or 3 years. It's going to take more than 10 years. But it's a transformation that changes also the way that software and hardware are designed because it decouples them one from the other. And let's start to talk very briefly about our content in these cases. ST has created this new family, 32-bit family of MCUs. So these are MCUs and eventually we'll integrate MPUs in the future, step by step, where we have a number of functions that we take care for this hub, for this capability to aggregate, transform, and move data. In order to be future-proof, we need to be able to guarantee a certain number of characteristics, among which I think there are these 5 that are important. First of all, we need to have best-in-class real-time processing over energy. Best-in-class because the ratio needs to be optimized. High, as high as possible. We need to be able to process real-time data with low power. It's still in the end a vehicle. It's still a car that works on the road. It needs to react in microseconds, in milliseconds maximum, and it cannot consume a lot because it's still self-contained energy. It does have to have hardware and software virtualization, which also means isolation. We need to put together multiple applications inside the same ECU in order to aggregate, in order to recombine them and make them more efficient, and to eventually allow this future-proof. The fact that you can update software while leaving hardware is based on the fact that you can have these isolation virtualization capabilities. We need to have adaptive safety and security. Adaptive means that during time you can change the level. Safety changes, as we have noticed. Security also changes. It becomes more and more complex. So we need to add more, be able to additionally have additional crypto algorithm and so on. And then connectivity. We are all about aggregating data and over-the-air update. Essential functionality, which ST has brought with new technology to the next level of efficiencies. In these cases, I say that this is the place where the cooperation with a company like Micron becomes important. The efficiency in memory, in being fast, in throughput and low power at the same time, represent a value that is fundamental and foundational for a long-term hardware future-proof platform. On top of that, the different type of memory, from the RAM to the DRAM, are going to be used depending on the level of abstraction in the zone. Some level will be high, so DRAM will appear. In some cases, it will be lower, depending on the vehicle. It will be only SRAM or non-volatile memories. All of this just to say that the cooperation and the integration between partnership to create this soft-defined vehicle is essential, because all the values of the defined vehicle lies into the software, into the capability they have to continually upgrade and update the software. And with this one, I'm going to finish, hopefully on time. I think it's going to be 10 minutes, right? Just stating our thoughts. Just going to read it. This is, in ST, our experience shows that innovative products capture the imaginations and increase the confidence and accelerate the transformation of mobility that is so much needed, and it's going to happen. Essentially driven from what I said at the beginning, the fact that through soft-defined vehicle, we are increasing, or the OEM will be increasing their own values, and they will recreate value for their investors. With this, I thank you so much for your attention. Thanks a lot.